Video, I'm going to show you how to conduct the dependent and independent t-tests using R. So we're going to do the dependent t-test first. We're going to use the same data that was used in the OLI textbook. And the first thing we need to do is to load that data in. So you can go to your files in the bottom right pane here. And for me, I keep all these files on the desktop, right? So I navigate to the desktop, and the file we're looking for is called beers. And there it is, beers, which is our data. And then I click on it. It asks me confirm if I want to load this. I say yes. And now I can see in the global environment, I have my data, 20 observations, has 2 variables. And if I want to take a look at these, I can click this little icon to the right. And then notice that up in the top left pane, I've got a new tab that includes my beers data. And so we have a before, a vector for before drinking the beer. And I believe these are times, so 6.25 seconds for the first person, 2.96 seconds. And then after drinking the beer, a second timing, and a total of 20 individuals. Okay, so to conduct the t-test for the dependent samples, I need to identify the 2 vectors that I want. So I want the before and the after. So I'm going to enter the beers and then the $ after. I'm going to enter this vector first because I want it to be subtracted from. And then the beers $ before is going to be the second vector entered because I want this to be subtracted from the after. And that way we can see what the change over time is. In this case, we have a hypothesis about what we might observe, and that is that it's going to take longer after somebody drinks beer. So the alternative is going to be, and notice in quotation marks, we say greater. And then finally, in order to identify this as a dependent t-test, we need this final argument, paired equals true. All right, so I'm going to execute this code. And down in the console, we can see our results. So here's our value of t, 2.58, 19 degrees of freedom. We can see the p-value is definitely less than 0.01, so it's a statistically significant difference. And we can also see the mean difference of 0.5015. Notice that the output doesn't actually tell us what the means before and after were. So if you're interested in that, and usually you are, so I included 2 more commands here. So the mean of the beers before and mean of the beers after. So if we execute that code, we can see that the average time before drinking beer was 4.96. And the mean after drinking beer was 5.46 seconds. This is about a half a second slower after drinking the beer. And it's a statistically significant difference. All right, so to do the independent t-test, we're again going to use the t-test function, but it's going to look a little bit different, and we need a different data set. So we're going to be looking at the looks data set, again from the OLI textbook. So I need to find the file first, navigate to it, and click on it. Yes, please. And if I want to take a look at the data, I click this icon. And now we can see here's the looks. We've got 2 variables, score in the first vector, genders in the second. Gender is either male or female. The first column has scores. And I believe that these scores, the higher the score, the more that the person emphasizes looks in a potential romantic partner. And we want to know, is there a difference between males and females in terms of how much they emphasize looks? All right, so here, the t-test, you'll notice the different way that we structure the code here. This little squiggly line means dependent on. So we want our dependent variable first, score, and it's dependent on gender. And notice that these are the same titles of our 2 variables. Okay, so score is dependent on gender, and we have to tell R where to take the data from. So the data comes from the looks data set, and here the alternative is going to be less. We're predicting that men will emphasize looks more and women will emphasize looks less. Right, so if I execute this code, here we can see that our t-test is negative 4.66 approximately. Degrees of freedom is 182.97. Why is this a decimal? Well, that's because R always conducts the Welch's two-sample t-test as opposed to a straightforward, just independent t-test. And our p-value, 3.07, that this is to an exponent of negative 6, meaning that we have to move this decimal place 6 places to the left. So it's 1, 2, 3, 4, 5, 6. In other words, there's 5 zeros in front of this 3. So basically the p-value is almost 0. All right, so it tells us that our alternative hypothesis with the true difference in the means is less than 0, right? That's what we had indicated in our code. And here it tells us that the mean for the female group is 10.73 and the mean for the male group is 13.33. So this is a statistically significant difference, and it indicates that men in this sample emphasized looks in romantic partners more than women did. All right, so what if you accidentally put in the wrong directional hypothesis? So instead of putting less, you put greater. Let's see what happens. Well, notice your t-score remains the same. The group means obviously remain the same, but notice what happened to the p-value. The p-value is now 1, and that's an indication that you put in the wrong directional hypothesis.